£22,000 spent on retrofit one EPC band gained. Here's what went wrong. Here's a scenario that illustrates one of the most common and expensive mistakes in home retrofit. A homeowner with a Victorian terrace spends around £22,000 on energy improvements over 3 years. They're motivated, they're doing their research, they're getting reputable installers in. 3 years later, their EPC has moved from E to D, one band. That's not a failure of effort. It's a failure of sequencing. In this video, we're going to look at what typically happens in this scenario, the decisions that get made, why they seem reasonable at the time, and what a whole house approach to the same budget would have achieved instead. The property and the starting point. The property in this scenario is a Victorian mid-terrace, solid stone walls, a gas combi boiler that's about 12 years old, no loft insulation, and single-glazed sash windows at the rear. EPC rating E48. The homeowner's goals are reasonable and common. Lower energy bills, better comfort, Victorian terraces are often cold and drafty, and a longer-term intention to get off gas. The first decision they make is to replace the boiler. It's aging, it breaks down over winter, and a new A-rated combi seems like an obvious upgrade. A smart thermostat goes in at the same time. That decision makes sense from an asset management perspective. From a retrofit perspective, it's the wrong place to start, and we'll come back to why. What was spent? Measure by measure. Let's go through the full spend over the 3 years. New A-rated combi boiler, £2,800. The EPC moves slightly, from E48 to E52. That might seem counterintuitive given the cost, but the existing boiler, while old, wasn't catastrophically inefficient. The modeled improvement is small. Smart thermostat and thermostatic radiator valves, £600. A marginal EPC improvement, genuinely useful for comfort and day-to-day control of heating, not a major efficiency measure on its own. Secondary glazing to the rear sash windows, £3,200. A reasonable decision for a listed or conservation area property where full replacement isn't an option. Noticeable comfort improvement, especially near the windows. Modest EPC uplift. Internal wall insulation to the front elevation only, £6,500. This is where the bigger spend starts. Insulating one wall is better than nothing, but the other walls are still letting heat out. And there is another problem, where the insulated wall meets an uninsulated one, you get a weak spot in the thermal envelope. That weak spot gets colder than the surrounding surfaces, and cold surfaces attract moisture. Over time, that can mean condensation and damp. Loft insulation. Partial coverage, £800. The loft was accessible but awkwardly shaped around water tanks and joists. The installer covered what was easy. The coverage isn't complete, which limits the benefit. Solar PV, £8,000. The largest single spend. The EPC rating moves meaningfully at this point. The SAP model rewards solar heavily. But the system is sized to the home's current energy profile. A home that still has uninsulated walls, partial loft coverage, and single-glazed windows at the rear. When the rest of the fabric is eventually improved, the system will be oversized for the building's actual demand. Total, £21,900. EPC, E48 to D55. One band. What went wrong? The insider's analysis. From an expert insider perspective, the problem here isn't the individual measures. Most of them are reasonable in isolation. The problem is the absence of a whole house plan and what that absence costs. The boiler replacement first. As an asset management decision, the boiler is old and unreliable. It's understandable, but from a retrofit standpoint, a new gas boiler at the start of a decarbonization journey locks in gas infrastructure for another 15 years. And it does nothing for the building fabric, which is where the real heat loss is. The partial internal wall insulation is probably the most technically problematic decision. Internal wall insulation on one elevation of a solid wall terrace without a plan to address the remaining elevations creates thermal bridging at the wall junctions. It also moves the dew point, the place where condensation forms, toward the interior of the remaining uninsulated walls. In a poorly ventilated Victorian property, that creates moisture risk. The solar PV sequencing is a common and costly mistake. PV is sized at installation to your current consumption and heat loss profile. Do the fabric work first, reduce your demand, and you'd size a smaller, cheaper system that covers a higher proportion of your actual needs. And the partial loft insulation reflects what happens without a project manager or retrofit coordinator overseeing the work. Each installer does their bit. Nobody is responsible for the whole building. What a whole house plan would have looked like. Now let's look at what the same £22,000 could have achieved with a whole house approach from the start. Step 1. A proper retrofit assessment, not an EPC, a detailed survey by a retrofit assessor or architect who looks at the building fabric, measures heat loss, checks ventilation, and identifies the right sequence of measures. Cost: around £400. Step 2. Full loft insulation to 270 millimeters, properly covering the entire area, including around tanks and joists. Cost: around £700. Step 3. Draft proofing. Doors, sash windows, suspended timber floor perimeter if accessible. Cost: around £300. Underrated, fast payback, immediate comfort improvement. Step 4. Internal wall insulation to all external elevations. Properly specified and sequenced with correctly detailed junctions to avoid cold bridging and a ventilation strategy included. Cost: around £9,000. This is the same measure as before, but done completely and correctly, significantly more impactful. Step 5. Heating controls. £600. Step 6. Heat pump, size to the improved fabric. The boiler upgrade scheme grant has been available at £7,500, but grant availability changes, so check the current terms before you plan around it. With that grant applied, the net cost of the heat pump comes to around £3,500, and because the system is sized to a well-insulated building, it is smaller, cheaper to install, and runs more efficiently. Step 7. Hot water cylinder insulation if applicable. £200. Total, approximately £1,400–1,700. That leaves £7,300 unspent, or available for solar PV, now correctly sized to a genuinely efficient home. Estimated EPC outcome with this sequence: B to B, potentially touching C without the heat pump included. Same budget, roughly 4 EPC bands gained instead of 1. And a building that actually performs: lower bills, better comfort, and a heating system that works with the fabric rather than against it. What every Victorian terrace owner should know: Victorian terraces are the hardest category of UK housing to retrofit well, and they're also one of the most common. There are millions of them. Solid walls, whether brick or stone, lose heat faster than cavity walls and are significantly more expensive to insulate. Internal wall insulation is usually the most practical option, but it reduces floor area. It requires careful detailing, and it must cover all elevations to work properly. When you tighten up an old building, reduce drafts, add insulation, you change how it breathes. Victorian houses were drafty by design. That ventilation was uncontrolled and wasteful, but it was ventilation. Seal the building without addressing ventilation properly, and you get condensation, mold, and poor air quality. A retrofit plan for a Victorian property must include a ventilation strategy. It's not optional. The grant landscape will keep changing, but the physics doesn't. A solid wall property needs fabric-first retrofit regardless of what incentives exist at any given time. Don't let grant deadlines drive sequencing decisions. That's how you end up with a heat pump in a cold building. And finally, get a retrofit coordinator or architect involved before you start spending significant money. The cost of that advice is small relative to the cost of doing things in the wrong order. The scenario we've looked at today isn't unusual. The homeowner wasn't careless. They were motivated and spending real money. The problem was the absence of a plan that treated the building as a whole system. Our EPC action plan is a few pounds. It gives you a structured, step-by-step guide based on your EPC band and property type, what to do, in what order, and what to check before spending anything significant. It won't replace a full retrofit assessment for a complex property, but it will give you the framework to avoid the most expensive sequencing mistakes. Link is in the description, and if you're earlier in the process, the free EPC checklist is also there. That's the right place to start if you haven't looked at your EPC properly yet.